Hey, this is 11.2, Build Understanding. This lesson is titled Graph Polygons on the Coordinate Plane. So before we get going, we need to learn what a vertex is. A vertex is the point where two sides of a polygon intersect. Let's look at these figures. We have figure 1, figure 2, and figure 3. A polygon is a closed plane figure formed by 3 or more line segments that intersect only at the endpoints. So the only one of these three figures that is a polygon is figure 1 because they intersect and there's more than 3 lines. Figure 2 is not a polygon because though there's 3 line segments, it doesn't connect here. Figure 3 is not a polygon because there's only one line here. There's only one line segment here. So choose all statements that apply about figure 1. The figure has straight sides. Okay. It does not have curved sides. They are all connected, and it is a polygon. Okay, B, it does have straight sides. They are not connected, so it is not a polygon. And this last one, that oval, it has curved sides. It is closed, but because it has curved sides, it is not a polygon. Okay, task 1's done. Let's look at task 2. You can classify polygons by the number of sides they have. Triangles, quadrilaterals, pentagons, and hexagons are all examples of polygons. So remember, triangles have 3 sides, quadrilaterals have 4, pentagons have 5, hexagons have 6. And if you want to even throw an octagon in there, those have 8. Okay, this next one, describe the polygon with vertices 2, 5, 7, 1, 2, -6, and -3, 1. It might be too hard if you're online to do this, but if you're in your book, it will be nice and easy to put these on. I know sometimes in your book this doesn't show up, so that's okay. So our first one we're going to put is 2, 5. So I'm going to run to 2, and I'm jumping up to 5. And I'm going to label this one F. Our next one, 7, 1. So I'm going to run to 7. I'm going to jump to 1. And I'm going to label that one G. It's important to label them. Okay, G. Apparently it's just going to look like a C. Our next one is 2, -6. So I ran to 2 and then I fell down. Okay, there we go. Sorry, ignore that dot right there. This is H. Our next one is -3. So I ran backwards to -3 and then I jumped to 1. And this is letter J. I hope your dots look a little bit better than mine, especially if you're in your book. You should be able to get your dots in there. So I sketched the graph of the point, and then we're going to connect them by drawing straight lines. So try your best. Line, 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 line. Not the best, but that's okay. You guys hit save, I'm not going to hit save. If you go right here, that's what it's supposed to look like. So I look pretty similar to that. So let's answer some questions about it. The graph FGHJ has 4 points. Oh, sorry. Ooh. Not 4 points. It says blank points above the x-axis. So we look right here, above the x-axis, we have 3 points. And blank below, that's 1. To the left, we have 1. To the right, we have 3. Right there. And I'm going to go ahead and refresh up here. Classify the polygon you drew by the number of sides. there are 4 sides. It is a quadrilateral because it has 4 sides. How many vertices does a polygon have? It has 4. Okay, we're done with task 2. Let's look at task 3. You can find this on page 351. An architect is drawing a plan for part of a bridge that makes a right triangle. Remember, a right triangle, it has a 90-degree angle. The coordinates of 2 vertices of a right triangle are A, -3, 5, and B, 2, 4. Sides AC and BC will form the right angle of the triangle. What are the coordinates of vertex C? So let's say I just read all of that. And does not look like my graph is popping up. Well, it doesn't look to appear like my graph is going to show up. So even with hitting a refresh button and waiting a little bit, it's not popping up. So we're just going to answer the questions about it. We're going to choose the statements that identify the locations of points A and B on the coordinate plane. So A is 3 units to the left of the y-axis. That's right. And A is 5 units above the x-axis. B is 2 units to the right of the y, and it's 4 units above the x-axis. Sorry we couldn't have the picture on here for it. It just wasn't loading on my scope, and now it is loaded. So I can put that on there real quick for you so you can see what that looks like. So A was at -3, 5, which is right here, and we're going to label that as A. Obviously, it's not, there you go. B is at 2, 4. Okay, so if you can see, we are 5 above, 2 to the left, sorry, 3 to the left, because our dot is right here. Right here, 1, 2, 3. Then we are 4 up and 2 over, and that's how we got all of those there. Go to B. A right triangle must have one angle that measures 90 degrees. Is there more than one possible location of the vertex C? So if I look at here, to make a right angle, I would either need to be right here, or I could be right here. So there is more than one location. We could be at 2, 6, or sorry, 2, 5, or we could be at -3, 4. And if you check back on your graph, those are those points that I pointed out to you. Okay, let's look at D. They have A and B on there for us. And we're going to plot C and draw a triangle ABC. And it's going to look something like this. So I could either have C here, or I could have C here, and I just drew my line across to have that diagonal there. So the right angle in ABC is at vertex C. Because if we look right here, the C is in the corner of it. Okay, draw a new right triangle in the 4th quadrant of the coordinate plane. And there could be a lot of different ways that you draw this right triangle. They don't give you much things. So I could have a dot here, here, and here. That gives you a right triangle because this is 90 degrees. You could have put it a lot differently than that too. You just have to make sure it's in the fourth quadrant because it told you to put it in the fourth quadrant. What are the signs of the x and y coordinates of the vertex of the right angle of your triangle? They both should be negative. They should be positive, negative, because you're in the fourth quadrant. Are the right triangles that you drew all polygons? They are all the right angles are polygons. Right triangles are closed figures, and they are made up of line segments that intersect only at their endpoints. How can you plot 3 points on a coordinate plane that cannot be vertices of a triangle? You can plot them on the same line. If you plot them on the same line, they're going to be in a straight line. Okay, we're on our last task for this lesson. Okay, this is a building in Copenhagen, Denmark. An architect is designing a plan for a new building inspired by the Credit Crystalline building in Copenhagen, Denmark. The building will have faces that are parallelograms. So if you look right here, parallelogram. It's like a box that's kind of squished to its side. Okay, we got that. Without right angles. The parallelogram does not have right angles. The architect plots 3 of the 4 corners of one face. So we have our first one they put on here is -5, -2. So I'm going to go to -5, and I fell down to -2. And we are going to label that one Q. Our next one is R. We're going to go to 1, and then we fell down to -2. So R. Then our last one they gave us is -2, 3. And this is S, which is a really bad S that I just drew. Let me rewrite my S. Well, my S is just going to be bad. This is S. There you go. S right there. There we go. Much better. Okay. Okay, what must be true about a parallelogram? That adjoining sides must be congruent. Adjoining sides must be parallel. All angles must be congruent. Opposite sides must be congruent, and they must be parallel. Those are our ones. So opposite sides of a parallelogram must be parallel and congruent. Adjoining sides cannot be parallel because they intersect a vertex. If all pairs of adjoining sides are congruent, the figure is a rhombus. If all angles are congruent, the figure is a rectangle. Okay, now we need to figure out point T. Is there more than one possible location that we could put point T? Okay, possible locations are 4, 3, -2, -7, and -8, 3. Because to keep it like a rhombus, I can have it in different, not rhombus, a parallelogram, I can keep it in different spaces. Okay, let's look at D. One of them that you could use, I'm going to use 4, 3 right here, and this would be T. So I plotted this point. You could also plot this one right here or this one up there. And that's all there is for this one, because the next one brings you to the next lesson. So we are done with Build Understanding.